For year 11 methods, we're going to look at exercise 6b, question 6a. So we want to write this polynomial division in this form. Okay, so what does it actually mean if I go, say, 15 divided by 4? I can write it as, well, 4 goes into 15, 4 goes into 15 3 times, and you've got remainder 3. Okay, so you've got 3 over 4, like that. Okay, because you've got 4 goes in 15 3 whole times, and then you've got 3 over 4 left over. Okay, so it's similar here. You're dividing this polynomial by x minus 1. You'll get a quotient and a remainder, and the remainder is over the what you divided by in the first place. So it's like the same thing here. Because we divided by 4 in the first place, your remainder is going to have a 4 over 4 at the bottom. Okay, so first things first, we just got to do long division. So we've got x minus 1 cubed plus 2x squared plus 5x plus 1, leading term divided by leading term here divided by leading term there. So that gives me x squared. I then multiply this with that. So x times x squared is x cubed, minus 1 times x squared is minus x squared. I subtract 2x squared minus x squared is 3x squared because it's a plus. Move the 5x squared down, leading term dividing by leading term. So 3x squared divided by x. That's 3x. You put the 3x at the top, and then you multiply this by 3x. So you got 3x squared minus 3x. You subtract 5 minus 3x minus 3x is 8x. Drop the 1. Then leading term divided by leading term, that's 8. Okay, so plus 8, multiply this with 8, so x times 8 is 8x, negative 1 times 8 is negative 8, okay, and then when we subtract, we got 1 minus 8, so it's 9. So that's our final remainder. We stop. Remainder. So you could write like this. You can go P of x is equal to d of x multiplied by q of x plus remainder. Okay, or you can go P of x divided by d of x, which is what we have here, equals, now we've already divided by d of x, so that disappears. You get q of x plus r on d of x. So essentially what we have here is P of x, which is just x cubed plus 2x squared plus 5x plus 1 divided by x minus 1. And we know that the quotient is given by this. We've got x squared plus 3x plus 8. X squared plus 3x plus 8. X squared plus 3x, whoops, 3x plus 8 plus the remainder. Okay, so what do we have as a remainder? We've got 9 over our original divisor, which is x plus 1. So our a value is 9. Okay, so that's how you do 6a basically. It's just getting you to write it in this form rather than this form. Okay. Next question. Question 2. Find a for each of the following. We know that for this polynomial, when it's divided by x minus 2, you get a remainder of 3, negative 3. So remember the trick. If you want to find the remainder of something, just sub in when that equals 0, basically. Okay, so you sub in x equals 2, or you find p of 2. So p of 2 equals 2. If I sub into the equation, I got 8 plus 4a plus 6 minus 5. And we know the result is negative 3, because that's what the remainder is. Okay, so the trick is, instead of having to do long division to get the remainder, I can use the fact that, hang on, if I use this as a dividend, and if I let that equal 0, if I let the value which gives me a value of 0 when I put it in. So if I put 2 minus 2, I get 0. So when I put x equals 2, this lets me get the remainders directly. Okay, so it's just a quick way of doing it. So I just need to rearrange and make. So I'll move 4a to one side, or I leave 4a to the side, and I move all the numbers to the outside. So 8 plus 6 is 14. 14 minus 5 is 9. Okay, 14 minus 5 is 9. So we've got positive 9. If I subtract 9 from that, it's negative 12. A equals to negative 3. Okay, done that. For B, we're again dividing by x minus 2 and get a remainder of 8. So P of 2 equals to 8. In other words, P of 2 means 8 plus 4 minus 4 A plus A squared equals to 8. And now, as you can see, we've got a quadratic, essentially. So I'll rearrange it. A squared minus 4A. And I'm going to move well, I can cancel the 8s. That just comes to 0, because there's 8 on both sides. And I'm left with plus 4 equals 0. Factorize it. This is a perfect square. A minus 2 squared equals 0. So, or you can use cross product if you're not sure how that worked. So A would have only one solution. A equals 2. Okay. Now, next one, factorize the following. Okay, so we're asked to do the full factorization list. Okay, remember, I can check for linear factors by subbing in P of 1, P of negative 1, P of 2, P of 3, P of negative 2, etc., etc. So let's try each one. Hopefully it's not a very large number. P of 1 is 2 plus 1 minus 2 minus 1. That actually works. That goes to 0. Okay, great. So remember, if P of 1 works, gives you 0, it means that x, the opposite, x minus 1 is a factor. Now, you can use long division, or you can use the method I taught you in class. So x multiply what gives you 2x cubed? It must be 2x squared, okay, because x times 2x. Because when I multiply this, I get 2x squared. I've got negative 1 here. What do I need to multiply negative 1 by to get negative 1? Positive 1, okay? Now, I need the middle term, so let's focus on the x squares, okay? So our goal is to have x squared. Now, out of this, what contributes to getting an x squared? Okay, so if I look carefully, the only thing that contributes to x squared so far is this. Okay, negative 1 times negative 1 times 2x squared. So we have negative 2x squared. Okay, so we need, okay, so in order to reach our goal of an x squared, we've got negative 2x squared at the moment. We actually need a 3x squared, okay, because without a 3x squared, I can't actually get my goal of an x squared. So this multiplied the middle term must give me a 3x squared. X times what gives me 3x squared? It must be a 3x. Okay, so that works. That should work. So you got negative 2x squared here, and you've got 3x squared there. So that gives you a positive x squared. Okay, so now we're not done yet. I need to factorize this. Now this is going to be a non-monic, meaning that you're going to have to use dots, not dots, cross products. So 2x, x, 1, 1, it works because 2x times 1 is 2x, x times 1 is x, so 2x plus x is 3x, so that works. So we've got our two factors, 2x plus 1, x plus 1, and we're done. Okay. So you can use long division if you're not comfortable with using this method, it's up to you. So I hope that helps.